Hello, everyone. We are here introducing a new keynote, this time for the NANOSTAR Project. We have the pleasure to have with us George Monteiro. He is CEO at Spaceway, COO at PenHack, and he's also a researcher at the Center of Mechanical and Aerospace Science and Technology. He is also Space Generation Advisory Council National Point of Contact of Portugal, so he also knows very well our network and our organizations. And then, George, I let you the word. The floor is yours. Please introduce yourself and talk a little bit more about this NANOSTAR project. Thank you.
Thank you so much, Pilar. Thank you so much for hearing me, to everyone. I'm here to talk to you about NANOSTAR. NANOSTAR is an international project funded by Interreg Sudoe. So it's a European project with Spain, Portugal, and France, 3 countries. And we just finished the project. We are finishing in 31 of May, but officially we finished at 11. So I'm here to present you the outputs of the project and to understand. We are preparing a new consortium, so if you are willing to and you like the outputs, so please feel free to contact me. So from myself, I think Pilar already told a lot. I am a PhD student at UBI. I'm a researcher. I am the CEO at Spaceway regarding space. I am the national point of contact at SGAC Portugal, and I'm also a ISU alumni. And my main focus has been mission analysis and design, and specifically to small satellites and nanosatellites. And I also love a lot of business and entrepreneurship. I have the mission to educate the new generation of explorers. So I try to involve myself in projects that allow us to teach and to educate the future ones. So if you want to contact me regarding business stuff, please send it to spaceway.pt. If you want to contact me about education stuff, please go ahead and join me at UBI. Okay, so let's start. As I told you, NANOSTAR is a project, was a project funded by European Regional Development Fund throughout Interreg Sudoe. And it basically is a collaborative approach for nanosatellite education and research. How we do this? We do this basically throughout a network of universities and research centers, and we can see it here. So the consortium is composed by 7 universities, so UPM, Carlos III in Madrid, and then in Portugal we have Universidade da Beira Interior, which I'm part of, and Instituto Técnico de Lisboa, as well as in France, Bordeaux, Isaías Paero in Toulouse, and Montpellier, University of Montpellier. And then we had also 2 aerospace clusters, Aerospace Valley and Madrid Aerospace Cluster. You should know them by now. And also business incubation centers, which help us as association partners, okay? So it's a big consortium. A lot of work has been done, and I'm pleased to give you the outputs of that. So let's start from the why. Why NANOSTAR? So the NANOSTAR project appeared because the Southern Europe, despite the strong influence in the space sector, has only 14% of the projects in the European nanosatellite sector. So if we see this map, we can check that there is a low volume of nanosatellites launched. In Portugal, 0, Spain 5, and France 6, which doesn't compare with the rest of the world, and it doesn't compare with our skills in the space sector, which we have a lot. So this is because the development of nanosatellite mission requires a lot of tools, competences, and it's difficult sometimes to launch nanosatellites in educational projects. So that's why it's necessary to have a network of expertise, a network of resources, and that's why we started NANOSTAR. So as you know, I will not be giving you a lot about nanosatellites, already should know a lot of that, but nanosatellites and small satellites are basically useful because they have low mass, they have low time to develop, they have low cost, and the utility is also very good compared with bigger satellites. So they don't substitute the bigger satellites, but they are very useful in a lot of missions. So we can do a lot of with small satellites. Here you see like nanosatellites like Planet Labs, constellations that they are doing global coverage almost in real time of Earth observation. And they have, nanosatellites have specific design philosophies that we want to address in Nanostar. So basically there is three. I took this from the small satellite groups of SJC, which I'm also part of. So basically we have three great design philosophies. The first one is we need to design it for cost. So we need to try to achieve 80% of performance with 20% of cost. So drive the cost lower. We need to keep it simple and stupid. So like no complex parts. Try to be like the most realistic that we can in safety and design margins. And we need to be able to do it fast and to develop the CubeSat or the nanosatellite fast. So we use standardization for that, like the CubeSat. Okay. This is the philosophies that we tried, and what we were trying to do here was trying to develop concurrent design philosophies and methodologies, and also softwares, okay, for education. So what is concurrent design, first of all? So as you know, the traditional method of doing engineering was the sequential or centralized design. So basically the sequential, you just pass the outputs of your results to the next person. So if you are like in the control, determination and control, you just pass the outputs to, for example, the electrical power, and then the electrical power pass the outputs to the systems engineering. And this, when there is another iteration, you need to go again and start again from the scratch, or with the new results, right? The centralized design, we have the system engineer in the middle, where he gets the outputs from everyone, which is already easier and simple, but it's simple if you have a concurrent design. So if you can change outputs between people as it goes the process. So that's what we're trying to do here. So concurrent design has become famous, especially in ESA. ESA has concurrent design facilities, which allow us to basically do these real-time, simultaneous, and co-located interactions with different specialists and disciplines. So basically, we schedule 1 week and we do the mission analysis and design in that week intensive. Then it's also allow us to share the data, to teamwork, to have an active participation of customers and users, because we can invite users and customers here to this week of mission analysis and design, which is basically the concurrent design approach. So that's why we try to start that. And about software, is already some softwares available in the market. So you know, ESA is developing OCDT, so they are developing their own tools about open concurrent design tool. Also CNES as the ITM-SIG, and there is some companies like Valley Space, who is developing a web concurrent design software, and REA, which is also have the CDP. So there is some softwares already, but none of them is open source and especially dedicated for education and research. So that's one of the outputs of Nanostar Project. So let's see what Nanostar Project is in the end. So Nanostar Project is a collaborative online platform to provide relative training to nanosat technology throughout student challenges. So how we do that? We basically developed two methods. So the first one, we developed CDF software, open source tools. So we call it the Nanostar software suite. Then we have the methodologies and educational content that we have. You can also check that in our Nanostar Project website. So there are like methodologies there, educational content, everything for free. Then we have the student challenges. So we organized student challenge as long as we did this project that allowed us to test some modules of the open source tools that we have been developing. And also the detailed design and test challenge was more research centered. We are going to check that. Okay, so the structure was basically this. So we started by cataloging the resources and expertise from the consortium. We started developing collaborative work tools, so concurrent design facility software models that we are going to talk in deep. And then we went for the methodology, and we started with the student challenges. Okay. The Nanostar software suite, which is one of the most important outputs of this project, was basically a set of integrated open source tools to aid the mission analysis and preliminary design phases of a nanosatellite mission within a concurrent design engineering methodology. So these tools then were going to be tested by students in educational challenges. So what were the requirements for these tools? So first of all, they need to be completely open source, so they can be used by students. They need to be modular. They need to easy integrate with other tools and oriented to education, and need to respect standards. And then they should be web-based. So like ValiSpace, for example, so you enter like Google Docs, you enter in the web, and you can remote work there and do collaborative work throughout these tools, okay? And the methodology, you can check them here. I will not go along, but you have tools, you have preliminary design methodology here, you have management methodology, you have a lot of documentation here that you can use. You had also joined the Slack channel that we used, but now it's not active anymore since the challenge is finished. Then we had PreDesign Challenges. We had 2 challenges. The first was a flyby mission to the moon. So we had more than 100 students here, and then we had the Roscoff Warmed mission, also more than 82 students enrolled. So 2 PreDesign challenges, and then we have the detailed design challenges, which each university have detailed challenges for the inside the university. So we had a lot of challenges related to nanosatellite systems. Okay, so if you want to check more about the Nanostar outputs, please check this YouTube video. I will not show here because it's a little bit long, but you can also go to the booth in the that you have in the Nanostar here in the quiz. So let's talk a little bit about the tool, because for us it's one of our main outputs. Okay. So the Nanostar software suite works like this. So basically you have a Nanospace user interface, which a centralized database, which it's in the web and gets the information from all the tools that we see. Okay. Then we have all the modules that we developed. All the modules that we developed, activity profile, structure, and budget. You have the tools that can integrate with the centralized database and get the outputs, and then we can work collaboratively here. So there is 3 solutions for that. You can manually integrating with the NSS web user interface, so you just put the outputs from the modules there, or you can do an interface with Angular and Python, or there is a full compliance. So you see here the state of these tools right now. So there is some work to do still. So you see that there are some of them that are already really integrate with the Nanospace user base really good. The other ones still need some work to do. But most of them are on working, okay? So let's see, for example, here you can also go to this GitLab and try the tools. So go ahead for that and give us feedback. So we have the tools there. You can just download them, you work with them, and basically one example here, for example, is the mission analysis module CSAT that it integrates with the Nanospace UI. And it's full compliant with the REST API. So the outputs come directly to the UI. Okay. So, for example, you see it here. So here you see the GSAT UI, and here the mission analysis model, and they are completely integrated. But please try it. There is a lot of more tools, as you can see. There is activity profile. There is for mechanical and architecture. It integrates with IDM. There is radiation. There is link budget. Most of these tools are like developed, but they miss some integrations. Okay. So let's talk a little bit about the next step of these tools. So I was telling you, so basically what do we need to do, and that's why we are trying to get a new consortium for trying to apply for new calls, because basically we need to test these tools now better, because they have been developing on the going with the challenges, and we want to really test them now that they are more developed. Then we need to simplify the installation and setup process. There are some tools that are really difficult to install, and you need to know some IT, at least some IT background, okay? But we want to simplify all this stuff. We want to produce tutorials and documentations, of course, and we want to develop more. We want to all the models to be full compliant, of course, and we also want to go ahead and try to go far away from the mission analysis and design with phase 0 and A, maybe up to C, as Valley Space, for example, is doing. Then we want to integrate more open source tools. We want maybe to have a pipeline management, maybe to have a MFBSE integrated, some maybe project management as well. And then what we really want to is to develop and launch a CubeSat that is modeled with NSCS to prove the concept that this can be done. Okay, that's why we need students. So why NSCS? So I already told you a little bit about why NSCS in a technical background, but why this can help the ecosystem of new space. So as you know, space access is now democratized. So there is like space players are growing fast, but so we have like developing countries trying to get us into the space race. We have startups, experts, consulting services, and all of these people sometimes can't pay tools that are really expensive in the space ecosystem. So if we have these open source tools that are like a little bit simplified, but they can do the purpose, we think that they will use it. Then you know that new space panorama is challenging for space technology players, so there is the need for training more people, because if we really want to go to the moon, go to Mars, we need more people to be trained. So this is the perfect tools to train them, and it's easy to drive down the costs. Then it's about education. So the education in universities, especially in the south region of Europe, is very theoretical. You know, you should know that if you are in Spain, if you're in Portugal, it's a lot is connected with industry needs. So we need industry to have a saying in the educational part, and we need to have these tools to give hands-on training to people. Okay, so let's pass this. This is like basically what I said with the SWOT analysis. So why we have the opportunity for the new space and the NSCS tools. So let's talk about the future, because I want to really go ahead in this. So basically, we have already confirmed the value. So we have already proved that this formula works. We have established the network. We have started like doing state-of-art tools. So what can we do more? So we can provide online education with these networks, and if more universities join us, we can expand these networks. We can also provide access to experts. We can provide technical support to people that use these tools, and we can provide access to collaborative tools as well. And we can go and continue educating students throughout hands-on activities. So for the sustainability of these tools, we are proposing two ways. So we are proposing to create a Nanostar Academy and a Nanostar Expert. Okay, so the Nanostar Academy is basically certified hands-on education in space projects. So we want to continue doing these hands-on challenges for students, and the Nanostar expert would be experts that would be willing to provide technical support on NSS or specialized knowledge about space project engineering topics. So maybe it could be like freelancers of space. So you see freelancers of designing, freelancers of marketing, freelancers of everything, but in space it's difficult to give consultancy. So if you have people that are willing to do consultancy using these tools and using the space knowledge, that would be part of Nanostar Expert Network. So basically, Nanostar Academy would work like this. So we have education managers that we are intending that will be startups and people that can and companies that can produce and prepare courses, so educational strategy, and they will recruit lecturers and industry, and then they will distribute to, for example, government agencies and all of this, and we can try to use the NSS for this. So here the advantage is that you have the industry having a saying, you have lecturers that can be paid for giving courses, and everyone wins in this way. So, and then the experts will be like, or specialists in specialized individuals who can provide support on specific domains, or IT support that they can give to the people that they are using the NSS tools that are open source, but you can have some troubles using, so you can need some support, right? And then the NSS manager will be part of the consortium of Nanostar, and then the users who really use the tools, right? So industry, universities, research and development entities, all of this. So organization model will be more or less like this, okay? So we have the Nanostar community that goes from users to contributors. The users will use the NSS to design satellite missions and systems, and the contributors will be the people that organize the academies and experts that give support. Who is part of the Nanostar community? All the ones that are interested in using the tools, and then we have the project, the Nanostar Software Suite Consortium, which will continue developing the tools and will provide, we'll get feedbacks, we'll fix bugs, basically this. Okay, our goals basically is that we are going to present it at EIC 2021. So if you are there, please go ahead and talk with us. I will be there as well. We are going to finalize a consortium this year to Nanostar 2. We are going to continue developing these tools. We are going to continue developing hands-on challenges, and then we want in 2 to 4 years to have finalized open source product, okay, that everyone can use and is easy to install, easy to use, and everyone can use it. And we want to project, develop, and launch at least a nanosatellite mission that is modeled by NSS. Okay. Then in 5 years from now, of course, the objective is that everything will be self-sustaining. So, like for example, GMAT, other open source tools in the markets, right? And that you have a community that grows organically and helps it to educate the new generation of people. Okay, so basically this is why we are here in the Nanostar in the ESGW workshop. So we want you to be aware that we are developing a Nanostar 2, that if you are interested, you can join. So please reach out, okay? And basically the Nanostar 2 project will have the following focus. So we will continue training engineers and students. We will continue developing the NSS up to the point where we have a product developed, open source, always be open source. And then we are going to develop documentation, training, tutorials. So if you have this capacity of producing content, education content, documentation, all of this, you can join. And then we want to develop a nanosatellite mission. Okay, so this is the needs I already told you. So education management, leadership, technical expertise, basically in IT and web development, and also communication and marketing. So this is what we are looking for. Okay, and basically this is the end. I think I am a little bit ahead of the time already. Sorry about that.
Thank you very much, George, for this presentation. It was very interesting to see the overall picture of NANOSTAR project. It was very clear. We are running a little bit out of time, but we have still 5 minutes to answer all the questions. Actually, your conclusions and your closing with NANOSTAR 2 project was very in line with the more rated question we have. So the question quote, how can a student engage when is the next competition, and what is the eligibility criteria, country of origin, years, educational background, etc.? So maybe you can answer.
So for the students, right? So to be honest, like it's closed. So we finished the project. The project was occurred for like 3 years already, but it's finished. So you cannot join any challenge because there are no open challenges. The criteria was everyone could join. So every university. So we have more participants from the ones from the universities from the consortium, of course. But there was some teams that were also from Africa, some from Asia. So like we want to open this for all. So when we have more challenges, they will be published in the website. You can check there the results that already happened in the previous challenges. So it's just let's try to get a second NanoStar, and then we open the challenges again.
Okay. Thank you very much. So we have another question related to the source code. You talk about the training material, the support, etc. But you also introduced NSS tool. So we have a question. What's the governance model of NSS as a free software project? And regarding the external contribution, how you will include external open source community contributions? Does NanoStar project decide what gets in and what is the roadmap for the product, for the tool? And is there any sort of assembly done by you, or by the people on the project? Yes,
okay. So technically speaking, I'm not the guy that can give the best tool, but about the governance, I can give you the answer. So basically, all the until now, the consortium was throughout these three countries. So the 7 universities that you saw. So what we are now doing is basically this. So we are like forming this new project management committee, which will be until the end of this year. I hope it will be finished. So we have like a consortium that will manage and will govern the tools. And then, of course, there is the possibility of contributors to join. That's why people and entities that want to be part, they can sponsor, they can be part of the community. They can help us to say, okay, we need these modules, we need these features. So please, this need to be a feature that we required. So they can include and they can give contributions to the consortium. Then we are also looking to a module of organization that contributors can be part of the committee. So if you are like contributing for developing the tools, for example, for 1 year or something, you can become an expert, right? You become an expert and you give IT support, but you also will allow us, will help us to develop the tools and the modules, and you will be paid for that. Okay, so that is what we are trying to organize here, but we don't have the concrete answer yet. So there isn't. The consortium just closed this month, so 31 of May it's the official end of the NANOSTAR project, and now we are like trying to get a new organization model and a new consortium. Okay, so the horizon is at the end of this year. For this consortium. Yes, so like this is the best time if you are interested in this project to join and contact me and say, okay, let's try to. I want to be part of this new committee that is forming. Thank you. So we have the time for a last question. So for which kind of mission are ideal nanosatellites? What is the purpose? Ideal mission. So. I mean, there is no ideal mission. So for the PreDesign Challenges, we did some missions. We designed these two missions. So we designed the flyby mission to the moon, which was like a 27U CubeSat. And then we also designed this mission for low Earth orbit with the science mission for Roscoe worms. But basically, this was just proposals. So for the detailed challenges, the universities worked inside missions that I already have been developing. So, for example, ISAE is developing CREMS. So it's a mission for astrophysics, I think. Then for radiation, something like that. Like basically, we don't have like a closed mind philosophy, right? So if the universities and if the research centers that are part of the Nanostar are developing their own missions, they can get students from other universities to work on those missions. So the missions will be chosen by exactly the users of the NSS.
Perfect. Thank you very much, George. If you have more questions, please do not hesitate to look for George in the Hopin platform and ask all your questions. I think you have also the contact detail, so please do not hesitate. And now we can pass to the break. We can also enjoy the networking part and the booth, and then coming back to the working groups after this coffee break. Thank you very much,
Thank you so
George.
much. Thank you so much for listening to me. Bye.